Here is the first part of our second little review section where we just go over the basics of graphs. Go over the Cartesian plane, the xy plane, coordinates of points, and how to get graphs equations and the relationship between the equation and the points on the graph. So first, just a really basic review here. To get the xy coordinates of labeled points, let's start with A. So the x-axis is the left and right here, and we're going to write the x-coordinate first, is the normal way to do it, and the y-coordinate second. So the x-coordinate is how far, if you start at the origin here, whoops, at the origin, how far to the left or right do you have to go sideways to get to it? That's x. So this time we have to go to the left, which is in the opposite of the positive numbers, and we have to go there by 3, so that means the x-coordinate is going to be -3. The y-coordinate is how far you have to go up from the origin, or you could look at it as from this point, how far you have to go up to get to the point. You can either go up first and then over, or over and then up, but in any case, the amount you go up by on either side is +3 because you're going up. Yeah, so that is A. Here is point B. So again, we have to go to the left in the x direction by 1 unit, so that's -1. And then the y coordinate, this time we're going downwards from the origin to get to that height. So that y coordinate is -3. Point C, you go to the right in the positive x direction by 2. And then in the positive y direction, how far up you have to go is 4. So that's 2, 4. The point D, that's 4, -4. Point E here is actually on the axis itself, on the y-axis. So that means the x-coordinate, that's how far you have to move to the left or right here. You don't move left or right of the origin at all. If you're going to get to E, you move 0 units to the right or 0 units to the left, either way. So the y-coordinate, because you go downwards there, is -2. Then let's look at F. F is on the x-axis. That means you don't go up or down in the y direction at all. You move 0 units in the y direction, you could say. So that means the y coordinate there is 0. The x coordinate is how far you have to move to the right to get to F, and that is 3 units. Number 2, we need to draw a big xy plane with x and y both between -6 and 6. I just did this with some software. Might take you a little bit longer than that, but that's okay. Now let's put a dot at each of these points. A is 0, 3. Let's start with this here. So that 0 means you don't go left or right at all. The 3 means you go up 3. So you go 1, 2, 3, halfway between 2 and 4. So that point right there is A. B is 2, 5, so that means we go to the right 2 and up 5. C is -4, 0. That's right here. The y coordinate is 0, so you don't go up or down at all from the x-axis. D is 3, -2. That should be over here. And then E is -3, 3. So the x coordinate is -3, the y coordinate is -3. That should be about there. All right, now, so that is part A. It's just drawing that there. Now for part B, so I did that one in green, I guess. For part B, let's do this one in purple. we're going to draw a little triangle at 3 points that have the same x coordinate as A. Then let's write the xy coordinates of these points. So let's see. The x coordinate of A, that's how far left or right we went from the origin to get to that point. That's 0 because we didn't move left or right at all. We just went straight up from the origin. So we need 3 points that have that same x coordinate, 0. So that same x coordinate as A is 0. Some other points that have 0 as a x coordinate, anything on the y axis here would work. So that one is 0, 6, excuse me. Here's another one. 0, 0 is the origin itself. Or maybe this one down here at -3, 0. I'm sorry, 0, -3. Okay, so though that's B, those all have the same x coordinate there, the same x coordinate of 0 at all those points. C is to draw a little circle at 3 points that have the same y coordinate as B. Okay, so the same y coordinate as B means you go up or down by the same amount. So there's 1 point here. That's actually a point that has the same x coordinate as A and the same y coordinate as B, but that works. The important thing is the y coordinate is 5. What else do we have that has that same y coordinate? We could go over here. We just need to go up or down by the same amount, or maybe over this way somewhat. As long as we stay on this same horizontal line. Whoops. Oh, can't really see it there. That horizontal line there where all of the points have the y coordinate 5. So we have this one, 4, 5, or the x coordinate could be negative, such as -5, 5 that we have there. They all have that same y coordinate. The thing I want to make sure you get out of this problem, and this is an important concept when we're analyzing graphs and doing more complicated things later on, is that if you have a horizontal line, all the points on a horizontal line always have the same y coordinate. And if you have a vertical line, then all the points on that vertical line will have the same x coordinate. Now, let's do the same thing for 3. We're going to need to draw another graph here. There's the graph. Let's draw a little square at 3 points on the x-axis. Okay, let's see. We've got that is one, that is one. Here's another one over here. Those points all have the same y coordinate. We're going to write their xy coordinates here. We have -6, 0, and -3, 0, and 4, 0. So let's see, which is true about these points? Do they all have x equals 0 or y equals 0? They all have y equals 0. So in other words, whenever you have a point on the x-axis, those points will always have y equals 0. So let's look at B now. Let's draw a dot at 3 points on the y-axis. Okay, so it could be 6, 0, or I'm sorry, 0, 6, 0, 2, 0, negative 4, 0, 3 is what I'm trying to say. Okay, so what is true about all of those points? Do they all have x equals 0 or y equals 0? They all have x equals 0. Okay, so the y-axis is all of the points where x is 0. It's kind of backwards, but that's how it goes. Let's look at this next one here. This time we have an equation. This is in the next item, by the way, which is why the problem number started off. We have this equation y equals 4x plus 3 to determine if the point is on the graph of the equation or not. Right. So what it means for a point to be on the graph is that when you plug in the x and plug in the y into that equation, it makes the equation true. It basically means that the xy points here are a solution of the equation. And if that's true, then when you make the graph of this equation, you're going to include all of those points that make it true. So let's see if these points are on the graph or not. So for A, we're going to plug in x equals 4, y equals 3, and nope. That will give you 3 equals 19. That means that xy point that we had there is not a solution of the equation, so it's not on the graph. With B, we're going to plug in negative 1 for y. That should be equal to 4 times negative 1 plus 3, and that will give you negative 1 equals negative 4 plus 3, and that is true. So that means negative 1 will be on the graph. If we try 1/2 5, let's see what that looks like. The y is 5. The x we're plugging in is 1/2. So we have 1/2 times 4. Plus 3. And let's see, 4 times 1/2 is 2. So that gives you 5 is equal to 2 plus 3, which is true. So that means yes, that point is on the graph. Okay, so anyways, I just wanted to do this just so that you know when you make a graph, it's going to have some points that are on the graph and it's going to have some points that are not on the graph. This equation in particular has these points. Let's say we have, if I'm graphing this, we've got negative 1 is going to be about there. And then 1/2 5, if this is 1, 2, 3 here, then 1/2 would be here, and we have to go up to about 5 here. The graph's not perfect. Anyways, 1/2 5 should be about here. And so it's got that point, it's got that point. If you draw a line through those points, you're probably going to get the graph. But then 4, 3 would be about over here somewhere, and that one is not on the graph. So the graph is going to be something, probably a line that goes through those points. Anyways, that's what that's about. Let's try this with number 2 again. For part A, we have x is -3 and y is 0. We want to see, is 0 equal to 1/3 times -3 plus 1? And it is. I'll let you check the arithmetic, but you got 0 equals 0. For part B, we're going to plug in y equals 1 and x equals 0. And that gives you 1 equals 0 plus 1. That works too. And for part C, we're going to plug in y equals -1 and x is 6. And that gives you -1 equals 2 plus 1, which is not true. Okay. All right, so that means this is a graph. If you're going to graph this equation, it would have these 2 points, but the first 2 points, A and B, but not the third point, C.